Hello, this video lesson is on the correlation coefficient, which relates directly to the coefficient of determination and linear regression. So if you have not watched those videos, then I would recommend that you go back and watch those. But otherwise, you will be more than ready for this lesson if you've seen them. I am going to show you how to do this one by hand first. Just because I normally skip it, but I want you to at least see a little bit of statistics done by hand. I think after seeing it, you might see the value in, I don't know, you probably already see the value in using a calculator because it's so easy. This is actually really easy to do by hand also, but like I've mentioned in previous videos, all of statistics can be done by hand pretty easily. It's all just subtraction, addition, and division, but it's very tedious, especially with large data sets. So this one is not too bad by hand, but you will see that it is quite involved. So the correlation coefficient, which is R, lowercase r, measures the correlation or relationship between two variables, x and y, according to this formula. So this is the formula that we're going to be using, and basically you're finding the z-score of x, z-score of y for every single x and every single y. You're adding all of those up, dividing by n minus 1, and that's your r. That's your correlation coefficient. So like I said, it's not necessarily difficult to do by hand. It just takes a really long time, but we can do it because we're smart. So a couple of things about the correlation coefficient. It will always be between -1 and +1. If it's not, then you know you've done something wrong. And a value of -1 indicates a perfect negative linear correlation. And the value of +1 indicates a perfect positive linear correlation between the two variables. The sign of R and the sign of the slope on the regression line should be the same. And the closer the data points cluster around the linear regression line, the stronger the association is between the variables. So the more linear, the tighter the line is in the between the line and the data points, the stronger the correlation coefficient will be. So based on that, I want you to try to match these graphs. So I have 4 graphs here, and then I have 4 answer choices, and I want you to match the graphs to the corresponding correlation coefficient values and see if you can get them. So pause it, try to match them up, and come back. You should get that this first graph was answer choice C, because it is very strong positive. So the strongest positive R value we can get is 1. And then the next one, you can see that it is falling, so we know it's going to be negative. And if you look at the two negative choices, we have -1 and -0.89. This one is going to be leaning more towards -0.89, because while it's strong, it's a very strong linear pattern, it's not quite -1. But the next one, we could say with confidence, that is a very strong linear pattern. So that's going to be A. And then the last one, it is positive, it's going upward. moderately strengthen, I don't know how to say that, between the two variables. So those should be your answer choices, your matching choices. Remember that the correlation coefficient shows how closely related the variables are. So these variables are strongly related in the negative direction. The bigger the x values get, the smaller the y values get in a linear pattern. So there's that. I have this data set that we have used in the previous two videos for linear regression and coefficient of determination. So if this is already in your calculator, then it's still there. These were the test scores that are associated with the study time of a calculus class over the course of 2 weeks. And so we are going to calculate the R value, the correlation coefficient, by hand. Yay! So to do that, let's look back at the formula. We have to find the z-score of each x value, the z-score of each y value, multiply those together, add all of those up, and divide by n minus 1, which means that before we can find z-scores, we need to know the mean of x, the mean of y, standard deviation of x, standard deviation of y. So before we do any of the other stuff, we need to do that. So I have here your first steps are to find the mean of x and the mean of y. You may use your calculator for this if you want to. So pause it, type that in your calculator. You're going to go to one stat calc, one var stats. And for x, you're going to put in L1, and then for y, you're going to put in L2. So pause it, try that, come back and check yours. I will say that it might be a little bit faster if you wanted to do, in this case, we do actually have two variables, so you could do two var stats. And then you can see I did two var stats, and if you just keep scrolling down, it gives you x and it gives you y. So you could just do one step that way, which is faster. And you should get x bar is 15, y bar is 82.75, I believe, but I rounded it to one decimal place. I went to one decimal past our raw data. And then in the same list, you should be able to find the standard deviation of x, which was about 4.7, nope, 6, sorry. And standard deviation of y, which is about 5.7. So these are going to be crucial for our next steps. We're going to be finding the z-value of each x value, the z-score of each x value and the z-score of each y value. I have created a table for this because I feel like it's just more organized to do it that way. I have each student here, there's 8 students. I have each student's study time, the z-score of each student, study time, and then the test score of each student, the z-score for each test score, and then we're going to be multiplying the two z-scores together. So pause the video, fill out this table, and then come back and check and see if we got the same thing. All right, so you should have gotten these values for your table. You might pause it and check all your values to make sure that they match. I went ahead, I did about 2 decimal places on these. I did 4 decimal places on these, just because I wanted to make sure it was accurate, really close. I didn't want to get any rounding error. So once you do all your z-scores, you multiply all your z-scores, and then you add up all the products of your z-scores, you should get something close to negative 4.9-ish. I didn't round, so I did negative 4.8712. In the next step, we're going to take that sum and multiply it by 1 over n minus 1, which is actually just dividing by n minus 1. So negative 4.8 712 times 1 over n minus 1 is actually just dividing by n minus 1. So that means the same thing. And in this case, n is 8. So we're going to be dividing by 7 because 8 minus 1 is 7. And you should end up with about negative 0.696 for our R value. Wasn't that fun? So meticulous and tedious. Okay. What does this number represent? What does it indicate about the two variables and their relationship? So remember that the R value tells us how closely related the two variables are, and the closer to -1 it is, the stronger negative correlation they have or relationship they have, and the closer to +1 it is, the stronger positive relationship they have. So this is closer to -1, which indicates that negative 0.696 indicates a moderately strong negative relationship between study time and test scores in this class, which means that in this class for these students, the more time they study, the lower they'll score on the test, which is crazy to me. So now I want you to input this data, if you haven't already, into your calculator, into Stat Edit, and then go to Stat Calc and go to linear regression, just like we did for linear regression equation and coefficient of determination. And go down to the very bottom. Once you do that, it'll say R, and see what you get there. Make sure it matches or is close to this. It should be very, very close to this, what we found by hand. So pause it, do that, and come back. So when I did this, I got negative 0.699, which is really close to what I got. So the difference is because of rounding. I rounded in my table, which made my answer a little bit off, but it's really close. And that is, if you can see in the calculator, it might be backwards for you, but that's down here. This is the linear regression option in Stat Calc. It's down here on the bottom. Now I want you to, this wasn't part of your notes, I added it later. I want you to square that value and see what you get. When you square it, pause it, square it, come back, and I want you to notice something. When you square that value, whoops, that's an accident, you should get 0.49. Now, this is so cool. I want you to go back to the previous lesson. You recognize that? That's the coefficient of determination. Isn't that so neat? So if you find the coefficient of determination, you could actually just square root that number, and that'll give you the value of the correlation coefficient, not the sign necessarily. You have to see that from the slope, but at least give you the numerical value so you don't have to do that entire table. So you do square root 0.49, and that gives 0.7, which is close to the value of our correlation coefficient. So if you have this value, you can square root it to get r, or likewise, if you have r, you can square it to get r squared. Isn't that so wonderful? So anyway, I just wanted to point that out in case you have a situation where you don't want to do this entire table, or you can, you were already given r squared or anything like that, then you can just take the square root and there's r. There you go. Well, remember, I already mentioned this, but remember, it does give you the numerical value of r, but you would have to know if it was negative or positive based on the slope of the linear regression line or the scatter plot or whatever. So anyway, there's that. I hope you enjoyed it. If you have any questions, let me know and I will be happy to help.